Hi guys, and welcome to Mindset Learn Extra Live. This is grade 11 maths, and tonight's show is brought to you by Liberty. Last week we covered quadratic inequalities with Natasha, and tonight our topic is simultaneous equations, and Heather will be taking us through it. Hi Heather.
Hi there, how are you?
I'm very good. Do you want to tell us about what we're chatting about?
Well, really what we're going to do is we're going to pick up on where Natasha's just left off with the grade 10. She's been doing some linear equations and quadratic equations. I'm going to kind of blend them into simultaneous equations. So nothing wrong with the grade 10s watching if they want to get extended a little bit, but good for graphs and going forward in your year as well. So stick with us.
Yeah, and grade 12s, keep tuning in. You know, you can always learn more and you can always learn extra. Guys, please send us questions that are related to the topic. If you stick with us throughout the year, we will eventually get round to the section you're having difficulty with, I promise. And next week, our topic will be transformations, very exciting. And lots of you have been asking us about our schedule. So if you are in a group, the topic next week is transformations. The show tonight will start off on a lesson on simultaneous equations, and then after the break we'll work through an example or two. Then lastly, we'll tackle your questions on the topic in the last 15 minutes of the shows. There are various ways to get hold of us, Mindsetters. You can chat to us on Facebook. That's facebook.com/learnextra. Our Twitter handle is @learnextra. We are also on PepText, which is awesome. You can join us on there, which is a free platform. I'll be posting a little link to it during the show, so you can get all set up and chatting. So, while you're watching, shoot us questions and we'll get round to them in the third part of the show. We also have a Casio calculator to give away tonight to one of the best questions on Facebook. We will be announcing the winner tomorrow on the page. And after the break, we'll be back with Heather.
See you then.
Hi grade 11 Mindsetters, hope that you're joining in for maths. We are now live and Heather is with us and we are going to answer all of your questions that you have. So guys, get asking on the page, get helping each other. We like, our mindset community. We're all about helping, all about making friends and learning more and learning extra. So let's get straight to the lesson. Are you ready for us?
I'm absolutely ready,
Fantastic.
guys, so welcome back. What I'm going to do is I'm going to take you through some real basic concepts, and then we're going to go straight into the simultaneous equations. Okay, so this one I'm sure that everybody's looking at and saying, oh, that's so blind. Okay, we want to try and solve for x. This is called a linear equation, okay? And of course, all of you are aware that what we have there is that x is equal to, when we subtract 1 from the other side, we get 7. Now that's the kind of thing that we started preparing you in grade 8 already, okay? Now what happens if, however, I take something like x plus y is equal to 8? Now can you see that now what I've done is I've introduced a second variable. It's still linear, but now I've got to solve for an x and a y. Now can you see that where this one here had a unique solution, the only thing that made that equation true was a 7. Whereas here, can you see that you have a whole family of solutions? So for example, x could be 1 and y could be 7. Or x could be 2 and y could be 6. Or in fact, x could be 3 and y could be 5. And I could go on like this forever and a day, choosing combinations of x and y that added to give me 8. Okay? Now what we did last year is we showed you that by introducing a second equation, so let's say we took x plus y is indeed equal to, is equal to 8, and in addition we took 2x subtract y was equal to 13. Oh, this thing is really all over the place. Is equal to 13. Okay, so what I've got here is what we call a system of equations. I've got x plus y must come to 8, and 2x subtract y must come to 13. Now you can see that if I actually took that solution 3 and 5, which would have worked here, 3 plus 5 does give me 8. But if I try to use it in the second equation, 2 times 3, take away 5, doesn't give me 13. So although it works in the first equation, it doesn't work in the second. So what I'm wanting to do is I'm wanting to solve these two equations at the same time. So I want to find a set of solutions that actually works for both, okay? And the big fat fancy word for that is simultaneously. Okay, so those of you who are adding to your vocab, simultaneously just means at the same time. All right, so in grade 10, we actually would have taken, just to scroll up, let's see where we're going to scroll up. Let's go back there. It's not going to work. So what we would have done is we would have taken our x plus y is equal to 8, and we would have taken our 2x subtract y is equal to 13, and we would have looked at these and scrutinized them and seen which one is it easier to get x or y isolated, okay? Now, if you have a look at this first equation, I'm going to call it equation 1, and I'm going to call this one equation 2. Equation 2, purely because it's second, and also because there's a 2 in front of the x, which makes it a little bit more difficult. Now, what I'm going to do is I'm going to take my first equation, all right, and I'm going to get it in the y form. So this tells me that y is equal to 8 subtract x. Now, it's exactly the same equation. I've just reorganized it so that I can now take it and substitute the first equation into my second equation. Okay? So I'm going to put 2x, subtract the new value for y, which is 8 subtract x, and put that equal to 13. Okay? Now, if I just take care when I multiply through, of course, these are the skills that hopefully have been drilled into you in the lower grades. So I'm going to get a positive x and then equals 13. And you can see now that I'm going to get 3x is equal to 21, and x lands up being 7. Now, knowing that x is a 7 now allows me to go all the way up here and to say, all right, I know that you are a 7, all right? So that means that I've got 7. Okay, doesn't quite like the color pen I'm using, so I've got 7, all right? Add y must come to 8, and so y comes to 1. Now that was just a quick recap of the kind of simultaneous equations that we did in grade 10. But now, can you see that this one here was linear, and that one there was linear as well, meaning that the highest exponent in either of those two equations was a 1. Okay, so now what I'm going to do is I'm going to quickly get down another one, which is purely grade 11, and it's going to have a linear and a quadratic. So let's take y is equal to, pen doesn't like me today, I'm not sure why.
I don't think it's personal.
Oh, really?
It's definitely not personal.
Possibly
Shame.
it just doesn't want to clash. It doesn't want to clash with my colors that I'm wearing. That's the problem.
Yes,
right.
such a
Y
beautiful
minus
blue.
2x is equal to negative 4. I think possibly when James dropped the pen, he's loosened the nozzle. But
Yes,
we'll look at
blame
that.
it on James. We'll blame it on James.
We'll blame it on James.
Yeah.
Okay. All right. So this is my system of equations, mindsetters. I've got y minus 2x is equal to negative 4. And I've got x squared plus y equals 4. And my instruction would be to solve simultaneously. Okay? So that's what we want to do. We want to find the unique solution that makes both of these equations true at the same time. All right, so what we want to do is follow exactly the same steps that we learned in grade 10. We want to look at our equations and we want to see which one is it going to be quite easy to get x or y on its own. Well, I'm going to take the first equation just because it's on the top level, and I'm going to call it my new equation 1, all right, after I've called this one and I've called this one 2. Okay, so if that is my original equation, if I'm going to get it into the y form, I'm going to say that y is going to be equivalent to, and of course I'm going to get 2x subtract 4. And that's my new equation 1. It's just had a bit of a makeover, okay? Same equation, I've just reorganized it so that it's useful for me. Now what I do is I take that and I substitute 1 into 2. Right, so just following quite systematically, I've got x squared, and now I'm going to substitute y. Now I just get into the habit of whenever I do a substitution, I put it into a bracket. Of course, if it's after a plus sign, it's really not going to have any effect. But if it was after a negative sign, then of course the negative would have to be distributed in. All right, so what I'm going to get is x squared, add 2x, and then I can see here that I've got a negative 4, and from the right-hand side, I've got another negative 4, so I'm going to get negative 8 is equal to 0. Right, now what we're doing is we're tapping into what Natasha did in the previous lesson. We're going to have to solve a quadratic equation, which makes sense because one of our equations was quadratic. Okay? So what we want to do is we want to create 2 brackets, and we want the firsts in each of the brackets to multiply together to get me to x squared, and then my factors of 8. Now fortunately 8 is either 1 times 8, all right, or 2 times 4. And I'm sure that you can see I'm going to be able to use the 4 times the 2, and to get a positive 2, I'm going to need a positive 4 together with a negative 2. All right, then obviously the 2 solutions for x are going to be x is negative 4 or x is 2. Right, now you would think, phew, I'm done. But in fact, I'm not done because I've got x's solutions, I don't have y's solutions yet. Okay, so let's see if we can get back our pink pen again. And remember that our expression for y, all right, was y is equal to 2x subtract 4. Now remember, this was my new equation 1. I could substitute back into my old equation 1 or my old equation 2, but always if you choose your new equation 1, it's going to have the variable that you're looking for as the subject of the formula. Okay, so I'm going to get either y is 2 times negative 4 subtract 4, or I'm going to get y is 2 times 2 subtract 4. So from this side, I'm going to get y is equal to negative 8 subtract 4 is negative 12. Okay, and then here we're going to get y is equal to 0. Now when we get one of these answers, I like my candidates to put them as a coordinate pair. So that means that what I would get here is I would write when x is 2, y is 0. And here I would say when x came out being negative 4, y had to be a negative 12. And guys, if you had to put these 2 answers back into your original equations, those would be the 2 unique solutions that make those equations true at the same time. Okay, Indiana, have we got anything coming through, or shall we give the...
Well, I think we're going to take an air break, but before we do, I do have some questions for you. It's all very exciting.
Okay.
Let me just have a look here. And Nelly wants to know, would it be wrong to solve the equation using the elimination method?
Okay, very good question. In grade 10, when both of your equations are linear, then you can use the elimination method, because then what you would have is you would have x and y, and then you would have, let's say, a 2x and a 3y, let's say, with, let's say, a plus and a minus, and some more other numbers on this side. I'm just making them up. But when they've both got the same power, okay, then you can eliminate. You cannot use the elimination method if one of them is linear and one of them is quadratic. Then you have to use the substitution method.
Fantastic.
But great question.
Yeah, so Anele, thanks for the fantastic question. Guys, get those questions in. Remember that there is no such thing as a silly question. Yeah, guys. Also, I just wanted to say a quick, like, Utsile, I just thought it was so sweet. He said, this topic I love and I understand, but a person cannot stop learning. And that's exactly what I said. Knowledge is power, Utsile. So yeah, guys, get tuning in, get sending questions, and we'll see you now after the break. Hi guys, and welcome back. Hope you guys are having a great session and you're really understanding everything that we're talking about. If there is anything that you are not understanding, please let us know on the Facebook page where you are struggling exactly. It'll take us much faster to help you out. Just in case you missed our links, we are www.facebook.com/learnextra, so like our page and get chatting to us. I'm also on Twitter, and that's @LearnExtra, and that's our handle, and that's with an XTRA. So let's get straight back to the lesson. Heather?
Okay, so welcome back, guys. I've got a second quadratic together with a linear simultaneous equation, which we're going to take you through. But I thought that maybe what I could do is give those of you who are able to multitask, I'm going to give you a challenge. So this is another system. X squared minus 2xy minus 5y squared is equal to 3, and x subtract y is equal to 3. So this is going to be your challenge, and what we'll do is at the end of the show we'll just give you the answers for that one. So while we're at a break or whatever, that's where you can get your teeth into it. Okay, so let's focus on this one here first. So again, your instruction would be to solve simultaneously for x and y. So if I have a look at my two equations, I think that here it becomes very clear that it's much easier to get x on its own than anything else. So here we have our first equation, and here we have our second equation. And I just very quickly want to make it clear that when I wrote that down, there was a blips. Oh dear. And now another one. Okay, this squared is not meant to be there. Okay, so there we go. It's just meant to be a 2x plus a 5y squared minus 57 is 0. Okay, so now you've got the picture. We look at the first equation and we identify that we can actually make a new equation out of it quite easily. And so the new equation is going to read that x is going to equal, all right, positive 18 subtract 4y. And you can see that I've organized it just so that it's a bit more user-friendly. I've got my 4y at the back rather than having it at the front, but that's just a kind of a personal preference. All right, so now remember my next step is I'm going to substitute this equation 1 into my second equation. All right, so I've got 2, and I'm multiplying in by x. All right, so this x gets replaced by its substitute. Okay, so those of you who play sport, if you get injured and a substitute gets sent in, they do the job for you while you recover, and then eventually, you know, they go off the field again. So all that you're doing is you're substituting an equivalent value for x. So 2 times 18 minus 4y minus 5y squared subtract 57 comes to 0. Okay? Right. I've got 36. All right, subtract 8y. Add 5y squared minus 57 comes to 0. Okay, let's see if we can try and extend this page. We don't have an extending page down here. So let's see if we can perhaps do something. Okay, let's drag it down. We'll try and scroll.
There's
magic.
extend the page.
There it comes.
There's
Okay.
extend the page.
So now what we've got is we've got 5y squared. Lost the pen again. So now we have got 5y squared. Okay, we have got negative 8y. We have got negative 21. And that comes to 0. Okay, now once again, guys, if your factorization of quadratics is a bit shoddy, this is where it's going to come in. Now, I know that Natasha mentioned that some of you have got calculators that can do this, but of course, if you haven't got a calculator, you're going to have to go off and somehow manage to trinomial factorize that into our two brackets. All right, now, on the one hand, you can be quite happy because 5 is just a prime number and it can only be as a result of 5y times y. Now 21 is also quite a nice number, although it's not prime. It's got the factors 1 times 21 and it's got the factors 7 times 3. Now it's a case of taking your best guess, and I normally encourage my candidates to go for the factors that are closer together. So I am going to try 7 times 3. So my factors of 5 are underneath each other, my factors of 21. Then what you do is you cross multiply. So if you take 5y and you multiply it by 3, you get 15y. And if you take 7 and multiply it by y, you get 7y. Now you need to have a good idea of how the numbers need to multiply by each other. Can you see that the back sign is a negative? And so that means that you've got to select two signs that are different. And as a result of combining these two, we need negative 8. So the only way we can do that is to have a negative 15 and a positive 7. Now this sign, whatever it is, be it positive or negative, it gets put into the top level and it creates the first bracket, which is 5y add 7. This sign goes onto the bottom level and we now have y subtract 3. Now you can see quite clearly that what we have is just to solve for y, and we get y here is equal to negative 7 divided by 5, or we get y is equal to 3. Now the one thing that you must not get scared of, right, we've now come up with the grade 10 template, and that's going to be a bit of a problem, so let's have a look if we can just find the template we were working on. There we go. All right, so wow, talk about a happy show here. Let's try and...
Are you winning?
No.
No?
No. Doesn't like my magic finger now. Okay. All right, let's just, we do have what we had before. We had y was equal to, thank heavens I did jot down some notes before, we had y is equal to negative 7 over 5, and we had y was equal to 3. So I was about to say that you must not always expect nice integral numbers. So if you get numbers like 2 and 4, that's a bonus, but sometimes you're going to get fractions. All right, and in fact, sometimes in grade 11, you might need to have used the quadratic formula on that first equation as well. Now, of course, what you have to do is you have to then get your x values. And if we recall, our x was 18 subtract 4y. So that is still visible for me, which is great. So 18 subtract 4y. All right, and what we're going to do is we're going to substitute in. Okay, maybe pink is better. No, it's not. Let's try over here.
Oh, it's really not liking us today.
No,
eh?
I think that I'm being serious. I think that when James dropped it, it actually
Heather, just
took
blame
the nibble.
James. Poor James in
Poor
studio
James.
is
His ears are
sweating now.
actually
He's
burning.
sweating.
Okay,
James, don't
so-
worry, James.
Okay, so what we've got is 18 subtract 4 times negative 7 over 5. Okay, and then the other solution will be x is equal to 18 subtract 4 times 3. And of course this one we can do without a calculator or any kind of effort, so we should over here get an answer of, it doesn't want
Nothing.
to work. Nothing. So really, I think maybe we should go for a quick break and see if we can't just work with the nib of this pen,
Guys,
if you don't mind.
we're going to have a look at the pen. We're going to dissect it. I do have a quick question for you that maybe you can answer.
Sure.
this one, I hope I get it right. So this one's from France. And he asks, what if I make the y the subject of the formula and divide it by 4 both sides to left with y only? Am I still correct?
Okay. France, of course you're still correct. The only problem with doing that is that what you're doing is you're introducing fractions. And what we try and avoid is introducing anything that could perhaps sabotage you. So, of course, when you had your original, here you had x, the coefficient of it was 1. Here you had y, the coefficient of it was 4. Now, can you see that through your suggestion, I could have isolated the 4y and then divided through both sides by 4. But then, the thing that you landed up substituting would have y is equal to, and then it would be something, a fraction, which had 4 as its denominator. Now, if you're confident that when you substitute in, you can manipulate fractions and you can multiply through and find common denominators, go for it. It's just that it's easier or perhaps less kind of open for error if you go for the one that's got the coefficient of 1. Okay.
Perfect. Okay. Fantastic. Guys, a lot of you are actually really, really loving simultaneous equations. I know Benele is. She's in love with simultaneous equations, writing maths tests tomorrow, which I know a lot of you are. And guys, you're going to ace those maths tests tomorrow. I'm telling you. We're going to go to a quick break, and we'll see you now. Hi guys, and welcome back for our grade 11 maths session. Hope you're all having lots and lots of fun. Guys, don't forget to get all your questions in, and please make sure you show me where you're stuck so we can get, me and Heather can go through them as easy and quickly as possible. We are taking questions in the last section of the show, which is coming up soon. I can't believe how quickly time flies. So Heather, I know you've got some more equations for us to sort out. Let's get straight to it.
Okay, so guys, we've got press stick on the pen, so hopefully we're going to have no more problems going forward. Okay, another set of simultaneous equations, and all I've done is I've tried to scare you with brackets, okay? But if we have a look at the two equations, can you see that this one is definitely the harder of the two? So I'm going to call that equation 2, and this one is definitely the easier of the two, and I'm going to call that equation 1. Okay. And of course, they've been a little bit sneaky because they've even given them to me in an upside down fashion. All right, so now what I'm going to do is I'm going to say from my equation 1, my new equation 1, I'm going to reorganize it, and this time I'm going to get y on its own. And so you can see that y is going to be negative 2x subtract 1. Now, of course, France is most probably saying, could he have isolated the x and divided by 2? Well, yes, of course. But then he would have been working with fractions. Now, the next question is, do I have to multiply this out first? Well, no, because look at what I can do. I can just say, I've got x subtract 1 squared, and I've got y. Now, y is going to be replaced with a negative 2x subtract 1. Then I've got my subtract 2 that was there originally. So this is my bit here that's being substituted for y. And then I've got that squared is equal to 5. Okay? Now, of course, it's just a matter of doing all the algebra crunching. So we're going to get x squared, subtract 2x, add a 1. And then here, before I square out, I think it could be quite good for me if I just quickly add my like terms in here. So I've got negative 2x, subtract 3, squared comes to 5. Right, so x squared minus 2x, add 1, subtract, I'm going to then have add. I wasn't following my basic rules. I must obviously square out first, and so when I square out, I'm going to get a positive 4x squared. Then I'm going to get a positive 12x, a positive 9, and I'm going to bring my 5 over at the same time, because as Natasha said in the previous session, the minute that you see you've got x squareds, you know that you're going to have to apply that rule of 0, that you're going to have to get a product to come to 0. Okay. Let's have a look at where we are now. We've now got x squared minus a 2x plus a 1, okay, plus a 4x squared plus 12x plus 4 is equal to 0. And that gives you a 5x squared, and it gives you a 10x, and it gives you a 5 is equal to 0. And at this point, one of three things can happen. Either you might need to take out a common factor, which is very clearly what I can do here. All right, and so what I get left with is a very nice, easy trinomial. Or, of course, you might need it to have gone off and done your trinomial factorization, or it might not have factorized, and in grade 11 that's possible, and you might have needed to have used your quadratic formula. Right, so here, of course, what we recognize is that this is actually x plus 1 squared, because it is a perfect square trinomial. And, of course, now, and I say of course, but many candidates want to know what happens to the 5. Now, remember that if you've got a 5 out there, what you technically do is you can divide through by the 5 on each side, and so you are just left solving x plus 1 squared is equal to 0. And that is just, compare that to this situation, guys, because it's these kind of things that trip you up. If the 5 had an x as part of its factor, then of course we would have three solutions here. We would actually have to introduce x is 0 as one of the solutions coming from there as well. All right, so finally here we're going to get x is negative 1. And of course it could be negative 1 again, so there's only one answer. So I've shown you that in fact, even although originally it was quadratic, there's only one answer for x. And of course, guys, you're then going to go back and you're going to substitute for y, and that's going to be pretty easy, and you're going to get y is equal to 1. Okay, I think maybe we might be ready for you to perhaps have a look at some questions of your own, or otherwise maybe take the challenge question. What do you think we should do?
Well, fantastic. Actually, regarding this question, well done, Andili, for getting it right. There are a few others, so well done, guys, and thanks for actually answering it on the page. So Heather, it's been amazing. They've been working through it. Well, you've been working through it too.
Okay, I must say that the simultaneous equations, if they've done their basics in grade 8, 9, 10, and 11, they feel a certain sense of achievement when they can do it in grade 11 and 12. So well done to everybody. Great. Yeah.
I can imagine. Yeah.
Okay, what are we going to do now?
Okay, well, we can either do, would you like to put up a challenge question?
Okay, well, should we put that challenge question up from before and take some, has anybody sent in any answers for it yet?
Yeah, they actually have.
Okay, so let's see what they're saying to us.
Okay, let's have a look. The answer to the challenge question, indeed, they got -1.
-1 for
Let me just have
x
a look
or y?
here. For x.
For x, okay.
Oh, no, wait, hold on. Answer to the challenge question is x equals 4, or 2, and y equals 1, or -1.
Oh, that's beautiful. That's exactly the answer that we want. Okay, so is there an alternative question, or shall we go through this one quickly with the mind-setters?
Okay. There is an alternative question, but I think we should go through it, because there's quite a few people. Danae's also put answers up, so a few mind-setters have put answers up, and I think it's time to work through it.
Okay, all right, guys, I was actually quite kind to you when I gave you this as the challenge question, because as it appeared on my text, it looked like this initially. Okay, it doesn't again, maybe a yellow this time, let's try. Okay, it looked like this. X squared minus 2xy minus 5y squared equals 3 equals x minus y. Now that's how it appears in my script, okay? I've taken that off of one of my school tests. But I decided to actually be quite kind to you, and I gave it to you in two separate equations. But can you see that it's essentially the same thing? It's saying that the quadratic is equal to 3, and the linear is also equal to 3. Now, if that's how it arrived on your examination script, then you would have to do this, and you would have to split it into the quadratic equal to 3, and then the linear equal to 3 as well. Okay, and you can see that while I've been talking, I've been taking a quick squiz, and I saw that it was easier to get the second equation either in terms of x or in terms of y. Now, if we take this equation, again, it's up to you and how confident you are. Can you see that if I wanted to get x on its own, that would be very easy. I would just have to transpose the y, and I would have x is equal to y add 3. But it would be equally easy to get y on its own by removing the y to the right and bringing the 3 to the left. That's a personal opinion, okay, and that's going to be your new equation 1. Right, what do we do with 1? And I know that Indiana is such a good student, she also knows by now that we have to put 1 into 2. Now this is a little bit more technical, because can you see that x, there are actually 2 places where we have x's. There's 1 and there's 1. Okay, it doesn't want to overwrite there, but you've got the general idea. So when you do your substitution, you are going to get 2 lots of substitution, and so let's try and get to that now. So you're going to have y add 3, all right? It's going into the place of x. Take away twice x, and x is being replaced by y add 3, and we're going to multiply that by y. Subtract 5y squared is equal to 3. Now I look at this and I immediately think of all the places where my students would make a mistake. And over here is where they would be bound to get a little bit confused as to what they are doing. Okay? So this is where we're having a bit of a problem again. So let's go again. Let's try. Okay. This press stick is obviously just 5 minutes.
To wear off.
5 minute press stick. Okay. So if we square that out, we're going to get y squared, add 6y, add 9. Now this is where the kind of pitfalls are. So what I would encourage my candidates to do is to actually remove the y from the back and to squish it there in front of the bracket. Because remember, if you've got 2ab, you could kind of switch it around and make it 2ba. So instead of 2 times the bracket times y, I'm going to make it 2 times y times the bracket. So I'm going to get a negative 2y squared. Then I'm going to get a negative 6y. Take away 5y squared, and while I'm at it, I'm going to transpose the 3 and get it equal to 0. Okay, so providing that we've done all of that correctly, we are going to land up getting y squared, take away 2y squared, take away 5y squared gets us to negative 6y squared. And then, look at what happens this time. We've got 6y subtract 6y. Now those actually knock each other off, and so we don't have a middle term, but what we do have is still a constant term of positive 6, and that's equal to 0. So this is a nice example just to show you that you might not always land up with your kind of quadratic trinomial. But what you do land up with is something where you could, first of all, take out a negative 6 and get left with y squared subtract 1 is equal to 0. And now, of course, this is where your grade 10 stuff comes flooding back again, because you know that that is the difference of 2 squares. And so you would land up factorizing it into y minus 1 and y plus 1. And that's why when that one correct answer said the y's are 1, I knew that he was on the right track. And so you get your y to be a 1 from this factor, and then your y to be a negative 1 from that factor. Right, so just finishing off the question, remember that we started off with x equaling 3 plus y, and of course we have our y being a negative 1, and we have our y being a positive 1, and so forcing that into there, we're going to get y. Did you see what happened? It kind of just went whoosh. So let's see what happens if we doesn't bring it back. Okay, so using a y equals a negative 1, we're going to get x is equal to 2. And here using a y is 1, we're going to get x is equal to 4. All right, nothing like keeping your cool under stress.
Yeah, exactly. You're doing so well.
Okay.
So well.
All right, so yeah. So guys, again, I like to have my answers presented properly, and so when x is 4, it works with y being a 1, and when x is 2, it works with y being a -1. And why I like that is because one of the other ways that we can solve simultaneous equations is through graphs. And if we were to draw two graphs, where the two graphs actually crossed each other, or intersected, or bumped into each other, that would be the coordinates, the x-coordinate and the y-coordinate of the point where the two graphs actually share a point in common. Okay, anything
Fantastic.
coming from the mindsetters?
We do have, okay, let me see if I can get this. Mpapuli wants to know, what do we do with the -6?
What did we do with the
negative
-6?
6.
Okay, all right, so let's just put that up for him. Remember, it was -6x squared plus 6 is equal to 0. Or in fact, it was y squared, but that doesn't matter. Okay, so what I said, well, let us take the -6 out as a common factor, and we left behind x squared subtract 1 is equal to 0. Now, just refer back to that last question where, if you remember, we had a 5 and then we had whatever, okay? And I mentioned that what we did here actually is we divided through by 5 on both sides. Okay, it really doesn't like the pink. It does seem to be more yellow. Okay, so if we divide by the 5 on both sides, then what we're left with is just a system of equations like that. Okay? So here, what he's doing, or should be realizing, is that what we do is we take and we divide both sides through by -6, and that means that we're left with x squared subtract 1 is equal to 0. Now again, some people might be saying, but Heather, why did you actually factorize that? Couldn't you have done that a different way? Well, yes, the beauty of maths is that there is never only one method.
Yeah, I've got a few of those questions coming through here.
Okay, all right, so that's the one way, but the other way would be to say, so x squared is 1 by transposing that to the other side, and then obviously if we take this side and we square root it, and we take that side and we square root it, we could get x is equal to positive or -1. Okay, hope that answers his question.
I'm sure,
Anything
I hope
else?
so. Okay, so this one is from Troy, and Troy wants to know, if you didn't change the 2 open brackets y plus 2y to 2y and then y plus 2, will you get the same answer at the end?
Okay, so just say it again if I didn't change the...
Okay, so 2 and then open brackets y plus 2.
2 open brackets y plus 2.
Close brackets.
Yes.
Y.
Yes.
Yes, if you didn't change that to 2, and then now he's changing the 2
Okay.
to 2y. Open brackets.
Y plus 2. Would I get the same answer?
Yeah.
Okay. All right. So let's just have a look at that. And I so want to hesitate because I'm scared that it's not going to work. But let's just take a look at that and take a look at that. All right. Yes, of course you'll get the same answer if you do all the processes correctly. Okay, so can you see that the danger here is that when you multiply this in, you're going to get a -2y and then a -4, but then that still needs to be distributed by the y. Whereas in this alternative is that you've already done the 2 by the y, and then you distribute in. It's just one of those safety mechanisms. So it's when we do maths, we try and be as sensitive as possible to the way that candidates make mistakes. And I just know that if I have something like this, let's say I have -2 times x plus 3 times -3, okay? Now I know that my candidates can do the negative 2 times the bracket, but then somewhere getting from the first multiplication to the second one, they make a mistake. So what I do is I encourage them to rather take the negative 2, multiply it by the negative 3 first, because those are both just single terms, and then to multiply it by the x plus 3. If they'd have done this process correctly, yay, hooray. But what I try and do is I try and just kind of get them to escape those pitfalls. Okay, next question.
Fantastic. Okay, let's have a look here. Well, Anissa said, thanks so much for recapping my grade 11 maths. It's such a pleasure. Okay, Rafense wants to know, can I make x subject of the formula? I did this and got the right answer.
Absolutely. And that's the beauty of the simultaneous equations. If you've got 2 equations, it's really up to you to decide which one is easier. And if you want to go for x, that's your kind of personal choice. I always just try and go for the variable that doesn't bring in a fraction. But, you know, really go big. If you want to, that's absolutely fine. And of course, the challenge to you is to try the same equation, making x the subject, and it'll work, and making y the subject, and it'll work. And I promise you, it will work as long as all of your procedures have been done correctly.
Fantastic.
Okay.
I can't believe it. I think we've actually almost run out of time.
Okay, well,
Hey?
apart from all the gremlins, I think
we did well. Guys, I really hope you enjoyed the show. Grade 11s, thank you so much for tuning in. Grade 12s, don't you forget, you are next, and you guys we're talking about financial maths, so stay tuned. Grade 11s, thank you so much. You were fab. See you again, same time, same place next week. Bye, guys.